Hey team, welcome back once again. We're going to continue with our trigonometry topic, all right? So we've just investigated where trigonometric ratios come from. So now we're going to move on to using those ratios to find unknown lengths of sides of our right-angled triangles, all right? So sometimes we are given an angle and then the length of one side of a right-angled triangle. So we can use the trig ratios to find either of the remaining sides. All right. So this kind of problem we can break down into 3 steps, and I want you guys to be doing these 3 steps every time. All right. It would make life a whole lot easier when we're first starting out doing these problems. So step 1, I always want you to redraw the figure. So if you're given the figure in a textbook, on a piece of paper that's not your piece of paper, I want you to redraw the figure and label the sides opposite, adjacent, and hypotenuse like we did a couple videos back. And I want that to be relative to the given angle. So remember, depending what angle you're given will change where opposite, adjacent, and hypotenuse are, okay? Step 2, I want you to choose the trig ratio relevant to the 2 sides you have. All right, so if you're given a bit of information of the hypotenuse side and you want to find the opposite side, you would look at the trig ratio that has the opposite and the hypotenuse sides involved in it. And then I want you to construct an equation with that. I'll go through an example of that in a second as well. And then step 3, solve the equation from step 2 for the unknown, okay? So 3 very simple steps, and we're going to run through those right now. So example 1, find x rounded to 2 decimal places. All right, so I've gone ahead and labeled my sides. All right, so in this case, we have 40 degrees down in this corner here. So straight away, I know my hypotenuse is here, so h. My opposite is opposite my angle, and then my adjacent here. All right, so as we have information for the opposite side, so we're trying to find our opposite side, so we know that's x, and then we know the hypotenuse, so we're given that as 12. So we have information in the opposite length and the hypotenuse length, so we need to choose the trig ratio that contains those 2 sides. So step 1, done, labeling our triangle, our diagram. Step 2, we need to choose the correct trig ratio. All right, so if we go down here and we're looking at our 3 ratios that we discovered in the last video, sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. So we need to choose the one that has opposite and hypotenuse involved, and hopefully you guys can see that the sine theta contains O and H. So that means sine theta is the trig ratio we are going to use. Step 3, all right, writing out that trig ratio in an equation form, okay, just like this. And then we're going to substitute in the information we know. So theta equals 40, opposite side equals x, and our hypotenuse equals 12. And now we're going to solve for x. So what we're going to do, we need x by itself. So we're going to multiply both sides by 12. And that's going to create 12 divided by 12 on this side, which equals 1. So we've got 1 times x, which is x. So that works out perfectly. And then we've got 12 times the sine of 40. Okay, so now that we have x by itself, we put 12 times sine of 40 into our calculator. And x equals approximately, okay? So most of the time, you're not going to get a whole number answer. Okay, so we need to put an approximate sign. You can either write your approximate signs like that, or you can write them like that as well, all right? Either way is conventionally correct. The question asks for 2 decimal places, so we have our 2 decimal places, and we also have our units, okay? Because we are finding the length of a side, it is super important that we put our units in. All right, so I want you guys to try this question here very quickly. All right, pause the video, have a crack at it. Once you guys have a crack, unpause the video and I'll go through the working out and the solution, okay? All right, welcome back. So we're going to run through this example, really clearly labeling the steps, all that sort of stuff. So step one of our process for working these questions out, labeling our diagram. So our hypotenuse side is the longest side. So you guys might have noticed that I actually forgot to put in our little right angle symbol there, okay? Super important to actually denote that this is a right angled triangle. So our opposite side is opposite our angle given, so that's this one over here, and then our adjacent side is the remaining side. So that's step one done. Step two, we need to determine what ratio to use. So I see that we have information in the opposite length and the adjacent length. So to me, that's ringing tan bells. So we're going to actually, in fact, use the tan ratio. So tan theta equals opposite over adjacent, okay? Now we're just going to substitute in all of our information, okay? So tan, oh, that's really bad, tan 22 equals opposite is 10 and adjacent is x. All right, so this is a little bit different to the example that I showed above. Our x is on the denominator, but the process is still the same, all right? So we're going to multiply both sides by x. So this is going to get 10 by itself on that right-hand side. So we've got x times tan of 22, and that is equal to 10. So now we want x by itself, okay? So what we're going to do, we're actually going to divide both sides by tan of 22. All right, so just remember that dividing anything by itself will give us 1, and we want x multiplied by 1 to get x by itself, okay? So what this does, they cancel out to be 1. All right, so we're left with x equals 10 divided by tan of 22. And if you jump onto your calculator, 10 divided by tan of 22, x is approximately equal to 24.75, and our units are centimeters, okay? So when the x is in the denominator of the ratio, like it is up here, there is an extra step of algebra that needs to be done, but it isn't a tricky step. So as long as you're following this process, multiply both sides by x, and then divide both sides by the trig ratio and the angle. All right. Hopefully that clears up how to find unknown sides. Please tune in next time. We're going to do some examples of finding the unknown angles. All right. See you guys next time.